Okay, I think that does it. A couple settings I had to change there, but it looks like we're good. I'm not blurry, and audio levels look good. Okay, so here we go. I'm not seeing a lot of questions from the class, so I assume that's good news, right? If you have concerns or you feel like you're getting behind or anything, please contact me. The sooner you contact me, the more likely I am to be able to help you get back on track so that you can finish this course successfully. Most of you are doing quite good. We just want to keep that up. We're moving through solving linear equations, like we kind of did that stuff. Just so you know, I think, let's see, what did I decide? 1, 2, 3, 4. 1, 2, 3, 4. Okay, so we have an upcoming section on systems of equations. So this chapter 4 that's in Canvas, and you can't see this yet because I haven't published it, but see how it says practice exam there? That's when we're going to have the first exam. So it's kind of a weird question. You ask, well, when's the first exam? And I say, well, it kind of depends on what your measurement is for when, right? I don't know the exact date that the test is going to be, or, and I'll talk about it as it will come up. In fact, I'll talk a little bit about it now, but I'll give you more specifics as we approach that exam. But don't necessarily think of it as a date on the calendar. Think of it as the exam will be after chapter 4 here, chapter 4 systems of equations. So that tells you right now we're kind of working in this area. We're working in chapter 3 area right now. As we move into chapter 4, you're going to know pretty well like how close the test is. When we're at 4.1, you're like, okay, the test is coming up pretty soon. And when we're at 4.5, you're like, well, we're done. That's all the material. The test is like going to happen immediately. So you can kind of tell where we are in terms of in terms of where that test is going to be. So if we look at when those, let's see if I can remember when those. Sure, I don't. Okay, good. So if I go in here, let me check. I want to do this off screen so I don't accidentally expose people's grades. So let me log in another window here so I can check something. So the systems of equations stuff is due October 10th. You can expect that the exam will be a little bit after that. So probably mid-October, you can expect that we'll get to the exam. Okay, so I don't know the exact date, but somewhere towards the middle part of October, maybe slightly earlier than that. So somewhere, starting around the 10th, since that's when the homework's due, I think it would be fair for me to put the test starting on the 10th, and maybe somewhere up to like the 15th. They're just depending on how the week falls. So you have a little bit of flexibility, or I do, as far as putting the tests when I think students will do the best. Okay, so does that make sense? That's how the test will work. So you can kind of guess, okay, so once we get through the part on systems of equations, that stuff's due October 10th. Right around then we'll have a test, give or take a few days, okay? So you kind of know roughly where that is. Many of you are caught up essentially on homework. Some of you have gotten a little behind. Just make sure you're caught up, right? And now is the time to catch up. A lot of students think that the time to catch up is at the end. That's if you want to fail a class, the time to catch up is at the end. Because you won't learn it. You're stressed out. You're not going to do a good job if you're rushing to meet the deadline. If you're behind, what you want to do is start catching up now. Maybe each day, work on the assignments that are due soon that you want to stay current on. So make sure you're going to get those done on time. And then maybe each day go back and do half an assignment from one that you missed. Just half the assignment, right? You don't have to sit down and do the whole thing for the whole evening, but do half an assignment. And if you're at this point, if you're 3-4 assignments behind, which a couple people are, that means you can be caught up in a week. And it's not like it has to take your whole evening. You just do an extra 15, 20, 25 minutes each night, and all of a sudden you're caught up, and then you're in good space for, to get the full credit for that homework, and then the material for the exam. That's one of the things that people get in this point mindset where everything's about points. But you want to remember, like, education is not about points, right? And I get why it's a distraction. I took a lot of college, right? I ended up with a PhD in mathematics, which means I took a lot of college courses. So I get it. Grades are a concern, but we seem to forget, and I'm not saying you as a class, I'm just talking as a society. We seem to forget that education is actually supposed to be about learning, right? So considering that it's supposed to be about learning, and we spend an awful lot of time just worried about points, those things don't necessarily go along. Sure, usually students who know more can get a few more points, but it doesn't exactly work one-to-one like that. It's not quite as clean as people would like to make it. So the goal here is make sure you're learning the material so that when you take the exam, you can do well on it. What'll happen is we get close, at least a week away, and sometimes like a week and a half away, I'll tell you what the test dates are going to be, right? Depending on how I choose to run it for this class. I'll tell you specifically what those dates are going to be. That gives you like another week to make sure you're all caught up and ready to go, do a little bit more studying, refine things, go, I still kind of don't really get this one section. I'm going to go back and look at it. Okay. And what's going to happen is you're going to have, I'll have a practice test for you, right? And there may be a written portion of the test that you have to submit. There may not. I'm still deciding. I've tried that in my other classes, and it worked really well. So we'll see how it goes in here. But there's probably going to be a written portion and an electronic portion, right? And then they'll each be worth a portion of the exam. You'll have a practice test, so you kind of know what to get used to and what to get comfortable with as far as the exam. So it's not like a complete shock. You can go, well, I worked through the practice exam. You use that practice exam as feedback to yourself as far as what you know and what you don't know. After the practice test is due, then you'll have the actual test. You'll go in and take that. I usually give a pretty big window. I don't see any point in rushing people. Online, if you rush people, they're just more likely to cheat. So, I'm hoping that you can all be ethical individuals and choose to be, good people, choose to make the right decisions and do things the right way. And if you're not being rushed, not try to cheat on the test. And then what happens, especially since even if you fail the first test, it doesn't necessarily lower your score, right? Because you get a retake. So that should right there, be an indication. Do I want to be a person who does good things? Do I want to be a good person? Do I want to try to do the right things? I mean, even if you do bad on the exam, it doesn't even necessarily hurt you because you get a retake. So you might as well just try to take the test ethically and see how well you can do ethically. See how much you actually earned as far as your grade, and see what you did. And if it comes up short, you still have the retake. You can spend a little bit more time studying, retake the exam, right? Remember, you do not get a retake on the exam at the end of the semester, the final exam, right? My department would not appreciate it if I gave retakes on a final. But we do have retakes on the midterm. So, or, whatever we want to call this, midterm or whatever. You can retake that. So there's really no reason to try to cheat on it, because even if you fail, you get another chance, right? So just try to do the right thing. Try to learn the material. I'm not one who throws surprises at you on tests, right? I know a lot of teachers, they take pride in making really, really hard tests, or trying to trick people on tests, or trying to, do some kind of very clever thing. I'm not about that. The problems that you see will be problems that you've seen in this class, right? The numbers will be changed, but I'm not going to come up with something real tricky. If you've done the homework, you should definitely know how to do the problems on the test. Okay, those should be, you should know how to do those. So just kind of start mentally preparing yourself for that. It's still a few weeks out. We still got 19 days, so 2.5 weeks at least, at the very least before the exam, almost 3 weeks. So just sort of start getting ready for that. Those of you who have fallen a little bit behind, get yourself caught up. Those of you who have sections that you got through but you're still kind of rusty on, go back and look at them, right? The more time you spend doing that now, the better you're going to learn, right? Remember, when it comes to learning, all the research shows if you just try to learn something in a really short period of time, not going to happen, right? You can't just sit down and go, I'm going to work this whole weekend and learn, special relativity for physics or something like that. Like, you have to learn it over a period of weeks for your when you learn, your brain is actually physically changing when you learn a thing, right? We like to just think there's like some kind of weird magic happening in our brains when we learn things. But, you can go on YouTube and you can watch videos of this. When a person is learning, the physical synapses in their brain are actually connecting. And when you think about learning from this physical standpoint, you start to realize, oh, yeah, you can only learn so much at a time because your brain can only physically change so much at a time, right? Just like you can't go into the weekend and say, I haven't bench pressed in 6 months, but I'm going to bench press for 48 hours straight in the gym and then I'll catch up for it. It doesn't work that way because your body fatigues. It's the same way with your brain when it's learning. It stops at some point forming those little connections. So if you've ever, I hear this from students all the time. If you ever come up to a teacher and you said, I knew how to do all this yesterday because I worked on it for like 6 hours and now I don't remember any of it. That's because you got past that early zone where your brain was still forming the synapses and it got fatigued and stopped forming those synapses. So you could do certain problems, but you didn't retain them because your brain didn't form those connections, right? If you want your brain to form connections, you do it every day for shorter periods, right? Not big, long periods. Same way with learning instruments. You're never going to have a teacher that says, don't worry about anything Monday through Saturday, but on Sunday, spend 7 hours learning your instrument. No teacher's ever going to tell you that because they know that doesn't work, right? So that's just kind of where we're headed. If there's any questions on that, we can talk about it, but that's the direction that we're going with things. And let's see. And I don't know. It's possible that October 10th date could get pushed out a little bit. We'll have to see how we go, right? I don't want to force people into a test they're not ready for. So if it looks to me like people are trying and they're consistently doing homework, but we're still struggling with that, it's possible I could move that date a little bit, right, to make sure people are a little more comfortable when we take the test. But for now, let's just say it's going to be October 10th. And if a week from now I realize we need a little more time, I can extend those dates, okay? But it depends. If I see people progressing and we're still going to come up short, that's one thing. If I see people not working at all and we come up short, then that's not a good reason, right? That's not about not having enough time. That's just about people not doing it. So, okay, with that said, let's get into some stuff. So let's kind of remember we've got this coming up. We've got a few units coming up that are important. And I think what I'd like to do, so today I'm going to sort of talk more about this equations of lines and talk about that a little bit more. Haven't really done problems from here. We've looked from linear equations and slope. We're going to look at equations of lines, talk about those a little bit. And then next time I plan on talking about functions. Now, it's entirely possible that that's going to take a day longer than I expected. So you can see how the schedule could possibly get pushed out if I can't cover the stuff that I want to talk about. So, but today I'm going to try to focus on this group right here, this equations of lines. So let's look at some three-step linear equations. And some of this you've seen, some of this we've covered a little bit, but I'm just going over it again to make sure everyone kind of understands what's going on. So here we have solve for x. Negative 8x plus 3 equals negative 6x plus 11. So let's remind ourselves, because all of these steps are going to be really important in the upcoming chapters. When you're solving systems of linear equations, guess what you're dealing with? Linear equations, right? So we need to be really, really comfortable with linear equations. So if you're kind of comfortable and you go, why are we going over this again? I'm kind of comfortable with it. No, you need to be real comfortable with it, right? And if you're real comfortable with it, great. Then you can blast through the homework and you'll be good to go. Okay, so let's look at this one. Negative 8x plus 3 equals negative 6x plus 11. Let's see if I can remember that. So negative 8x 8x plus 3 equals negative 6x, was it plus 11? No, I messed that up, didn't I? Negative 8x plus 3, oh, plus 3. I think I said 3, but then I hit 2. Equals negative 6x plus 11. Okay, that looks right. And again, maybe it was the other class where I talked about this the other day. You know, one of the most common, but you'll hear me say it a few times throughout the semester. One of the most common mistakes I see people do is just writing the problem down. When they write the problem down, they make a mistake early on, like how I had that a 2. When I first wrote it down, this was a 2, and I changed it back to a 3. It's probably worth an extra second or two to always double check that you did the problem correct, right? Because when I'm in class and I'm going around and helping the groups of people that are working on stuff, I would say close to half the time, a student raises their hand and they're like, you know, I feel like I'm doing it right, but it doesn't work. What am I doing wrong? And then we look, because they'll be like, it doesn't match the back of the book, or it doesn't match other people's answers. And what happens is they wrote the problem down wrong. So their work is all correct, but for the wrong problem. So always a good idea just to double check. This will be especially so when we get to systems of equations coming up in the next couple weeks, in that those systems of equations take a few minutes to solve. And it's a bummer if you spend 5 minutes solving a problem, you did everything right, but you realize I wrote one of the equations down wrong. And now I got to do it all over. So you can pat yourself on the back for getting the right answer, but you did the wrong problem. It's not going to help you when you're trying to do it, okay? So that's kind of a step to always look out for. Did I write the question down correctly? Now, having spent so much time talking about it, I better be real sure I did this correctly. So negative x plus 3 equals negative 6x plus 11. Okay, so what are the steps that we use here in order to solve this equation? Well, our goal is to get to the point where we have x equals and then some number. That's what we want. X by itself, no coefficients, no operations, just an x, and then an equal sign, and then some number. Okay, so how do I do that? Well, we have two rules that we use. One is called the addition rule, even though it allows subtraction, because addition is just adding a negative. And the multiplication rule, which also allows division, because if you think about it, dividing by 2 is the same as multiplying by 1/2, right? So the addition rule allows addition and subtraction. Multiplication rule allows multiplication and division. It's just a shorter name than always talking about the multiplication and division rule. Okay, so what does that addition rule says? The addition rule says that we can add or subtract the same thing from both sides of the equation. And if you think about it as a scales, like a balance, if the balance is balanced, then I add 2 grams to both sides, it's still going to be balanced. If I take away 5 grams from both sides, still going to be balanced, right? So that's the idea. So what you want to do, our first goal is to get the variable term on one side. So anything that has a variable, we get it on one side of the equation. Everything that doesn't, we put on the other side of the equation. And actually, I skipped a step because it doesn't matter here. Your very first step would be to simplify the left side and simplify the right side. But in this problem, that's already done because these are not like terms. We can't combine those, right? We can't add a negative 8x and a plus 3. Those don't simplify because they're not like terms. Same over here. So, for instance, if this had been like this, if it was plus 2 plus 1, you're going to get problems where it's sort of like that, where stuff is spread out more. Then the very first step you would have done is to combine these to be a plus 3. So your first step is to simplify each side as much as you can. Okay, so I would go, okay, plus 3 like that. So we have on each side, we only have non-like terms. Now that we've simplified both sides of the equation, we can start looking at using the addition rule to get the variable term on one side, the constant term on the other. Now, it doesn't matter which way you decide to do it. Some people might say, I want the variable term on one side and the constant on the other. And then another person does it backwards. You're going to get the same answer either way. It's just one of you will get like x equals 5, and the other person will get 5 equals x. But it doesn't matter. They mean the same thing, right? So let's take a look at our problem. So what do I want to do? Well, I can choose, right? I can choose to get my variable term on the left or the right. If you choose differently than me, it doesn't matter. It doesn't mean my way is better. It doesn't mean your way is better. It's just two different ways, two different choices to make when doing effectively the same thing. I'm going to add, why is it not? It's weird. Auto compile is on, but it doesn't keep updating for some reason. I'm going to add 8x to both sides. That's what the addition rule tells me I can do. I can add the same thing to both sides of the equation. So I'm going to add 8x. So when I do that, I just get 3 on the left. But when I add 8x on the right, negative 6x plus 8x is 2x plus 11. Okay, so it looks like I've decided then to get my variable term on the right. That means that my constant should be on the left. So now I'm going to subtract 11 from both sides. So 3 minus 11 is negative 8 equals 2x. And when I divide both sides by 2, so now we're using that multiplication rule. Multiplication rule says I can multiply or divide both sides of the equation by the same thing, and the equation is the same. Technically, we can't multiply or divide by 0. Like the rule excludes 0, but that should be pretty obvious. If we multiply both sides of the equation by 0, we just lose all our information, right? Won't be able to do anything anyways. So divide both sides by 2, and I get negative 4 equals x. And we can check this, right? Let's see. What if I plug x equals negative 4 into this top equation? That's how we check our work, right? The computer is going to check it for us because when I put it in there, it's going to tell me if it's right or wrong. But in the real world, you have no idea if your answer is right or not. You should check your work and make sure that everything seems reasonable. Otherwise, you're going to end up making bad number decisions. Okay, so if I plug this in, I get what? 32 plus 3, which would be 35. And over here, I'd get 24 plus 11, which would be 35. So yes, if I plug in x equals negative 4, I get 35 equals 35, which works, right? All you do is turn this x into negative 4s and check it. So let's see. Answer, negative 4. There we go, green check, right? So you can see they actually made different choices than me. They subtracted a 3 right out of the gate. Okay. They added 6x to both sides. Okay. But notice how they ended up with the same answer here, x equals 4. Ended up with the same thing, even though they made different choices along the way. So there's no right or wrong answer about like which order to do your addition subtraction steps in. It just goes, first of all, simplify both sides. Then use your addition rule, then use your multiplication rule, then check your work. That's the steps that you want, okay? So let's see. Not seeing any questions, so I take it students get that? Okay, identify linear functions from a point. This this isn't the one I was thinking of. I was thinking of a different problem. How would you do this? Which table of values represent a linear function? So what happens is, if you think about it, let's see if I can do this actually. Maybe I can try to have both of these on the screen at the same time. Let's see if we can go. Because I'll try to explain how this works. You can memorize how it works, but again, we're always trying to learn, right? The learning, not just the points. So let's take a look at these, which like one way that you could figure out if these are points on a line is to plot them. Now that's not what they want you to do, but it's going to help us see what's going on. So let me plot some points here. Negative 1, 3, 2, 0. Plus, this would be a much longer way to do the problem than you really need to. But I'm trying to teach you how to do it. Okay, so I've got these points. So here's the points from A. So I just took these points from A and I plotted them. Now I look at it and go, well, that's pretty convincing to me that those look like they lie in a straight line. Those look linear to me. But this isn't really what they want you to do in the problem, right? It's helpful, so we go, oh, okay, I see that's linear. It might be a nice way to check your work. So what is it they really want us to do in this problem? They want you to figure out the slope. Notice that the slope to get from one of these points to the others is exactly the same. I do what? I go over 1, down 1, over 1, down 1, over 1, down 1. Now I'm back on the point again. Okay, over 1, down 1, over 1, down 1, over 1, down 1. Here I am again. I'm on a point again. Over 1, down 1, over 1, down 1, over 1, down 1, and I'm on the point again. That means that the slope, if you use any of these points to calculate the slope, you're going to get the same answer. And that is a characteristic of a linear equation. If you take any 2 points on that thing and calculate the slope, you're going to get the exact same thing. Now, that doesn't mean you have to figure out every combination of slopes, because that would be, what would there be, 12 of them? I think there's 12 different slopes you could calculate. That's too many. You don't have to go through and do all of that. But you can just kind of see, oh, yeah, look, it's the same pattern from one point to another. Let's look at one that's not. So let's try B. So negative 5, 3, negative 2, 2, 4, 0, and 6, negative 1. Okay, did I get this right? Negative 5, 3, negative 2, 2, 4, 0, 6, negative 1. Okay. Now I've plotted the points from B. Now these almost, if you're not careful, you could almost convince yourself there's a line that goes through there. But if you're careful, these look like they are not in a straight line, right? So let's see. Yeah, you try to fit a line there. It doesn't look like there's any line we're going to be able to get to go through all of these at the same time, right? Play around with it, and then you can start to see, oh yeah, it's not going to go through these points. Right? Looks like it's not going to get there. So what does that mean? Well, depending on which points we choose here to calculate our slope, we're going to get a different value. So let's do that, right? So let's go through and calculate our slope here. Say for the first 2 points, so that, remember our slope formula, y2 minus y1 over x2 minus x1. So if I do that, m equals, and then we have our fraction. So if I take the first 2 points, so let's see our y values. So 3 minus 2 over negative 5 minus negative 2 would become negative 3, meaning that this whole thing becomes the fraction negative 1/3. And we can see if I got that right. Let's take a look. Yep, looks like it. So actually, if we change this to be negative 1/3, look, that looks like the slope of the lines through my first 2 points, huh? Looks like I got the slope right, but then it messes up over here. I can't go through these at the right time. So let's calculate the slope of these 2 points over here. So if I do that, right, hopefully everyone's comfortable with calculating slopes. So if I do that now, I'm going to get, in fact, let's call this first one m sub 1, and then we'll call another one m sub 2 equals the fraction. Okay, so for my second 2 sets of points, it's going to be 0 minus negative 1. That's my y values. 0 minus negative 1, which becomes plus 1, right? And then so 0 minus negative 1, 4 minus 6. And that all becomes 1/2. That doesn't seem right. Did I mess that up? Oh, because it should be 4 minus 6 would be negative 1/2. Right? Let's see. Oh yeah, down 2 over 1. So yep. So these 2 points have a slope of negative 1/2. These 2 points have a slope of negative. Oops, I'm not sorry. You can't see it on the thing. These 2 points we calculated have a slope of negative 1/3. These 2 points have a slope of negative 1/2. Well, then they can't be on the same line, right? Different points can't have different slopes on the same line. And you can kind of see this. Look over here. We go down 1 over 3. But over here, you go down 1 over 2. Well, then the slopes can't be the same if the rise over run is different. Okay? So that's how they want you to do that point. So I think in this one, which table of values are I don't know if it's more than 1, but I don't want to go through all of them for class, but let's see. Yep, so it looks like it was just 1, the first one. So see what they do? Here's what they do, which is similar to what we did. They just take successive points and they keep calculating the slope, and see how they got negative 1 every single time? That means the slope was the same throughout. So that's all you have to do is just keep calculating the slopes in between each point, and then you're good. Okay, so that's how that problem works. Interpret linear equations in context. I think, didn't we do some of this, or was that the other class where we talked about this? If everyone's already comfortable with this, go ahead and stop me, but let's take a look. Hunter is going to the amusement park where he has to pay a set price of admission and another price for tickets to go on each of the rides. Okay, this happens at the fair. You go to the fair and they're like, it's $10 admission. Okay, great. And then you get in there and they're like, you can't do anything but buy food yet. So in order to do the stuff, you have to pay more money. You have to buy tickets or whatever, right? The total amount of money Hunter will spend is given by the equation y equals 20 plus 3x, where y represents the total amount of money in dollars and cents, and x represents the number of rides Hunter goes on. What is the meaning of the y value when x equals 1? Okay, so some great stuff here, right? So let's first break this down. Y equals 20 plus 3x. What could that mean? Can we pull out information that we weren't given in the problem just from looking at the problem? And the answer is yes, right? Because if it costs Hunter money to go on each... I don't know why my phone is blowing up this morning. Sorry, I got distracted by a notification. Okay, so if Hunter is paying more, has to buy tickets for each ride that Hunter goes on, which part of the equation do you think that is? Do you think that's the y? Do you think it's the 20? Or do you think it's the 3x? Well, y we've already been told is the total amount of money. So then y wouldn't represent the amount to go on rides, because y is the total amount of money. They told us that right in the problem. Okay, so then it's either the 20 or the 3x. Well, does the 20 change at all depending on how many rides Hunter goes on? No. That is in business what we call a fixed cost. It doesn't change. It's just a cost that's right there. What is the thing that's changing? Well, the variable changes, right? The 3x is the part that represents the amount of money being spent on Hunter's rides. So apparently for each ride Hunter does, it's gonna be $3, right? So you can actually break this down. We talk about this in my applied calculus class when I teach that. You can look at this as the fixed cost and variable cost and recognize it. Even though they didn't tell you in the problem how much it costs to get into the amusement park, and they didn't tell you how much it costs per ride, you can just look at it and say, well, it must have cost $20 to get into the park because that's the fixed cost. That doesn't change. And the 3x must be the part representing how many rides Hunter goes on, because that's the part that's changing based on x, and x, they tell us, is the number of rides, right? X represents the number of rides Hunter goes on. So that's already information. It doesn't say in the problem it costs $20 to get in, but we know that it does because we were able to read the mathematics. We were able to understand the mathematics. So see how you don't want to just blindly take stuff that's given to you in a problem. You want to interpret it. You want to understand it. This is the thing that's going to set you apart in the future is this kind of thinking, this critical thinking skill. You're going to be in the workplace with someone who just doesn't know how to do this problem but plugs stuff in. And then you're going to be sitting there going, oh, I know how to actually get extra information about this. And then at work, guess who's going to look like a better worker and get the promotion? It's going to be you who can actually figure things out. When you can figure things out and the people around you go, how did you know that? It tends to go in your favor, right? You're going to look good at work. They're going to think about you when there's promotion, stuff like that. So being able to break that down, that critical thinking piece, going beyond the question, is really helpful for being able to figure things out. Okay. So what is the meaning of the value, the y value, when x equals 1? Well, this should be pretty straightforward. They told us what x equals. X represents the number of rides Hunter goes on. So then what would x equal 1 mean? X equals 1 would be the amount of money spent to go on one ride. Right? I mean, it's literally just right there. So I know sometimes people get overwhelmed when they have to read this much, like a full paragraph. They're showing one of the downsides of screen time that people have is people are losing the ability to read more than a couple sentences at a time. But the good news is you can get over that with practice. So those of you who are able to work through a paragraph and read the whole thing and understand it, that's good. That's a good skill to have. So they tell us, X represents the number of rides Hunter goes on, and then they ask, well, what does it mean when X equals 1? So it's kind of just repeating back to the problem what it just stated. Okay, so the total amount of money Hunter will spend if he goes on one ride. That's what that is, right? Submit. There we go, green check. So they kind of walk us through it. Yeah, so $23 to go on one ride. Right. They do this. One of the reasons they do this is because it gets you doing a calculation in your head, and you're like, I just spent $23 to go on one ride, and then you realize, well, if I buy more tickets, that actually lowers my average cost. Right? So then you feel like you're getting more of a deal out of it, and then they get you to spend, but ultimately you're just spending more money. All right, let's do another one of those. Okay, an elevator travels down from the top floor of a skyscraper in height. Its height in feet is given by the equation h equals 500 minus 32t. So where h represents the elevator's height in feet, they kind of said that twice, which kind of a poorly written sentence there. Anyways, h represents the height in feet. Remember we talked before about picking smart variables. In this case, they choose h and t for height and time, and you're probably not going to mix them up. You're probably not going to go, I think that height is time and that t is height. That doesn't make any sense, right? So it's really helpful to pick smart variables like they did here. It says t represents the time in seconds. What could the number 500 represent in this equation? So again, they're getting it to that type of question that I just asked a moment ago. What would this be? There's a fixed value and then a variable value. Well, what would how would you get this 500? Well, what would happen when t was equal to 0? When t was equal to 0, this whole second term would just go away and you'd get h equals 500. So what does that mean? When t is equal to 0, h is equal to 500. How do we interpret that in terms of the problem? What is time 0? When 0 seconds have passed, what do we call that? That's oftentimes in your science classes, you're going to call that your initial condition, but it means when you started. Right? If 0 seconds have passed, that's right when the experiment started. Oh, so that's when things started. So what we can say is the height of the elevator at time 0 was 500 feet. The elevator was 500 feet tall when we started measuring. Okay? So let's see. How can we best answer that? The height of the elevator at time t equals 0. That's true. There might be a better answer, a little more specific. Nope, these are all wrong. So it's the first one. And there we go. We got our green check. Okay, so that's why you have to be able to go beyond not just, oh, I can take this equation and I can crunch some numbers. I can plug numbers into it. You have to figure out what they mean. You have to be able to tell that story. Otherwise, anything you learn in math classes in high school and college will literally be meaningless to you if you can't figure out how to apply them and interpret them into real-world situations. Because, I probably said this before. You'll hear me say it again. In the real world, everything's a word problem. Everything's a word problem, right? No one ever comes up to you and says, hey, I got this equation. Solve it and get back to me. That's never going to happen, okay? Okay, interpret linear graph in context. Oh, linear graph in context. Here we go. So now you're looking at the graph. You don't have the equation like we had a minute ago. Now you're looking at the graph. Another really good exercise to get you to interpret what's going on here. So Faith signed up for a streaming music service where there's a fixed cost for monthly membership and a cost per song download. Her total cost is given by the linear graph below. What does the y-intercept in the graph represent? Always a good question. Okay, so let's understand this. So it looks like here's the number of songs. 1, 2, 3, 4, 5. This is number of songs, and it's labeled. And then we have total cost per month. So, okay, so we're kind of getting the sense of it. It starts at $6.99 or $7, depending on exactly where that thing is starting. And then it goes up by values for each song that she spends. Okay, so what are our possibilities for what does the y-intercept on the graph represent? Well, ask yourself this. How do I get to be the y-intercept? How do I get it to that point? Well, that would happen when the number of songs that she purchased is 0. So what would you have if you have the number of songs purchased in a month was 0? What are we talking about then? Well, we're talking about just the subscription price, right? So it makes sense if she bought 0 songs, that's where we get the intercept, and that's where we get this price represents the base value. That's that fixed cost that we talked about a few minutes ago. The fixed cost for this is the cost of the streaming service, which is looks like maybe $6.99, and then you would pay the variable cost, which is an additional cost for each song. Okay, the base cost of the streaming service per month, yeah, I think that's the one we're going to go with. These other ones are all wrong. Okay, so I'll submit my answer. Yes, there we go. Right? So even though they didn't say in the problem that the subscription service costs $6.99 a month, we figured it out. And obviously this problem is silly. It's a made-up person. But think about that. That's where you want to get with your mathematics, is where you can figure out things that were not just what people told you. Right? A lot of times people think that's what being smart is that you can repeat what other people have already done and said. That's not. That's just being a robot. Right? That's all the jobs and stuff that are going to be replaced in the next 10 years, is all the jobs where people are just repeating the same thing they were shown to do once and they do it again and again and again. Those are all the jobs that are getting replaced by software and robots. What you want to be able to do is take things, interpret it, and come up with information that people didn't already know. That's a lot harder to replace with software and jobs. Some of those with software and robots. Some of those things will still get replaced, but it'll take longer. Okay. Oh, somehow this one ended up in here again. That's still a good one to do. And lines from 2 points, always good. I like these problems. Really good to practice. We covered these last week, and we don't have time to cover them now. But those are always a favorite for me to put on tests, because if you can do this problem, right? What is an equation of the line? I should say, what is the equation of the line that passes through these 2 points? In order to do that, step 1, you calculate the slope. So you just showed me you know how to calculate slope and what it means. Then you plug in your information to the equation of a line, and you get the equation of the line. To me, if you can do that, that means that you have a lot of the skills necessary to like go on to a stats class or something like that. So that's a very good test problem. Don't be surprised at all if you have to do that on the exam one way or the other. Okay, and it looks like with that we're out of time. So as always, I'm going to shut down the YouTube stream. Anyone who wants to talk with me, hop over into Zoom, and I'm happy to answer any questions for you or help you out, or whatever we need to do so that you can be successful and comfortable in this course. So thanks